This question introduces something called the bandpass sampling theorem that suggests that we're able to successfully recover a signal after effectively undersampling it, sampling it at a rate less than the Nyquist rate, so less than twice the signal's upper frequency limit. So for this question here, or this signal here, the maximum frequency component is 25 kilohertz. So your Nyquist rate would be twice that, so it would be 50 kilohertz. And what we have is sampling at less than that, basically at half the Nyquist rate. So you'd expect the signal to be undersampled and therefore impossible to recover. But the bandpass sampling theorem allows for successful recovery of signals that have this kind of a gap where there's effectively no signal in this region here between 0 and 15 kilohertz. So the question is saying, consider this and look at the signal after sampling and tell whether or not we could recover the original signal after undersampling. So we're going to sample at 25 kilohertz and see what would the spectrum look like. Okay, so the sampling rate is, in this case, equal to F max, 25 kilohertz. So we'll have multiple replicas of this same spectrum spread across the frequency axis. Our first replica will be centered at 0 hertz, so that's this pair here. At 0 hertz, that's this and this. So these two are centered at 0. We then have a pair centered at the sampling frequency, 25, so at 25K. We have the same spectrum here, so these two, but shifted to be centered at 25 kilohertz. So that's this and this. And we'll have the same two centered at negative 25. So that's this and this. And then we'll have a third or a fourth replica centered at twice the sampling frequency, so at 50. So if I were to write this as centered at Fs and 2Fs, it would make more sense. So centered at Fs and centered at 2Fs. So that explains these two, and it explains these two. So these two are centered at 50. And then we have a replica centered at 75, which is 3 times the sampling frequency. So at 3Fs. And we can do the same for the negative axis. So basically we have this repeating pattern. So this is what the frequency spectrum looks like. There's clearly some overlap, but luckily because of this gap in the frequency spectrum, we're able to slot these in. So these seem to fit in nicely without interfering. So it still would be possible to recover our original signal. Remember, this is our original signal, this blue one. It would still be possible to recover it if we had a bandpass filter. So if we had a bandpass filter centered or with cutoff frequency of 15 and 25 kilohertz, we could still recover our original message. So if we had a band pass filter with cutoff frequency of 15 kilohertz and 25 kilohertz, we could still recover our message. So we'd be recovering this and this. So it seems that all of these replicas, they haven't managed to overlap our original spectrum. So we can still recover this without any aliasing. So perfect reconstruction is possible, even though we sampled at less than the Nyquist rate, at half the Nyquist rate, in fact.